Hello, students. We're going to study today open and closed interval in the calculus setting. So we're going to start with a comma b, excluding a, excluding b. This is what we call open intervals, where a and b are real numbers. So these notations, mathematicians were very lazy, and when we write that, we mean a and b are real numbers. So we're going to shorten the notation. So when we want to write that, we just write this. A and B belong to the real numbers. This is the set for the real numbers. So this means A and B are real numbers. All right. So A and B, A comma B are open intervals. Are there more open intervals, Professor? Certainly. For instance, we have A comma infinity or minus infinity comma B or minus infinity comma infinity. Those are also open intervals where A and B are real numbers. Thank you very much for watching that. Now let's focus on this other type of intervals. About we call A comma B. These are closed intervals. So this means this interval includes A and includes B because they have a square bracket. That's what we use to denote that the points A and B are both included, right? So these are closed intervals where A and B are real numbers. Remember, this means A and B are real numbers. Are there more closed intervals, Professor? Yes. Here are more examples. A comma infinity minus infinity comma B, and let's mark this black a little bit so you kind of recognize that they are going to be closed intervals, right? And also minus infinity comma infinity. They are closed intervals. You say, wait, hold on, Professor. You told me that negative infinity comma infinity, it's an open interval. And you're saying now that it's a closed interval? Yep, it's both. So take a look that all the open intervals have a round bracket. Round brackets, round bracket. I'm sorry, round parentheses, round parentheses, round parentheses, right? And what about the closed intervals? They have square. I wish we can have here square, but unfortunately, infinity is not a real number. You see what I mean? So I wish we can have also here like square bracket, but unfortunately, that would mean that that would include negative infinity, but negative infinity is not a real number. That's why we don't put a square bracket ever, right? On those. I wish we can have a square bracket here, but unfortunately, we cannot because these numbers are not real, all right? So these are closed intervals. So let's test our knowledge. Let's go ahead and take a look. All right, let's do this. So what about this? Is that open or closed interval? I guess that's open interval. What about this? That's a closed interval. Remember? I wish we could do this, but this is unfortunately not a real number. That's why that's a closed interval, right? Because typically we include both, but in this case we cannot. Let's go ahead and do the next one. How about that one? That'll be open interval, closed interval, open interval, open interval, open interval, open interval, open interval, closed interval. Wait, you said that it's open. Yep, it's both open and closed. What about this? This is closed interval. This is closed interval. This is closed interval. Do we have more? Yep. That is, wait, hold on. This is not closed interval. This is neither, right? That's neither. What about this one? That's closed interval. What about this one? This is neither. Are you confused? I hope you're not. You say, well, hold on. How come this is, you may say, how come this is closed, but this is neither? They look pretty much the same, Professor. Yep, they look pretty much the same, but this is infinity and this is 10. Get it? Oh, I get it. All right. So let's move into now open and closed sets in the real numbers in the calculus setting. What are the open sets? So let me tell you very simply that the definition for the open sets is the following. Open sets are unions of open intervals. Yep. That's what open sets are. What do you mean unions, professors? Unions, professor? What do you mean unions? Yep, you can join one or two or three or an infinite amount or 500 or an infinite countable amount or non-countable. That's like a union is just a union. You're just joining. How many? You don't care. As long as you join, as long as you join open intervals, that's an open set. And what are closed sets, Professor? Closed sets are just complements of open sets. Those are closed sets. All right, so let me give you an example. For instance, we have here this set. Let's do, for instance, right? For instance, we 0 through complement. That's the complement of an open set. So let's go ahead and take a look. Where is 0, 3? So that's the stuff inside, right? Excluding 0, excluding 3. And the complement of that is like from here all the way to here, right? That's the complement, excluding negative infinity. And also from here, from 3, including 3, all the way to plus infinity. That's a complement, right? That blue set is a closed set. It's a closed set, right? So that's it. Those are closed sets. So let me give you an example of an open set. Those are unions of open intervals. For instance, 0, union 5, union 9, 10 is open. Why? It's an open set. Or just we can just say only open, okay? Sometimes we disregard that and we just say, oh, that's open or open set. Why? Because it's a union of open intervals. This is 1, 2, 3, 3 open intervals. That's why that's an open set. Can you give another example, Professor? Yep. Let's do 0, 1, union 1, 2, union 2, 3, union 3, 4, union whatever. Keep going like that. That's an open set. Is an open set. Or sometimes we just say it's open. That's it. Whatever, right? There you go. Let's test our knowledge. Is this a closed set or an open set? Oh, shit, I don't know, Professor. Well, remember, this is a closed interval. That's going to be a closed set too. It's not only a closed interval, but it's going to be a closed set. Let me explain to you why that's closed. It is closed because that is equal, that is the complement of an open set. That is the complement of an open set. Which open set? This one. Negative infinity, comma 3, union 10, comma, infinity. That's the complement of that. And this guy right here is open, or is an open set, right? So it's closed because it's the complement of an open set. Take a look. If you forgot, here is the definition. Closed sets are just complements of open sets. All right, let's take a look at the next one. Open or closed? That's an open set because it's a union of open intervals. How many? One. This is an open set. Why? Because it's a union of open intervals. How many? Only one. This is an open set because it's a union of open intervals. What about this? Whoa, 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 whoa. This is the complement of an open set. Therefore, that's closed. That makes it closed. Why? Because it's the complement of an open set. All right, what about this one? That's an open set because it's a union of open intervals, and that is indeed an open interval. Let's take a look at this one. That's a closed set. Why is a closed set? Because it's a closed interval. In addition, it is also, remember, this is also the complement of an open set. Which open set? Namely, this is minus infinity, comma 1. That's the complement of that set. And this guy right here, this is an open set. So being this the complement of an open set, that makes this closed. Right, let's do the next one. So let's do that one, this union. That's a union of open intervals, therefore it's an open set. So we need to hear more dots. All right, what about this one? That's a closed set. Why is that a closed set? Because it's the complement. Remember, a closed set is the complement of an open set, namely negative infinity, comma 0. All right. So what about this one? This is a closed set. Why is that a closed set? Because it's the complement of an open set, namely 90, comma plus infinity. All right, that's the complement of that. Right, what about this one? That's a union of open intervals. Therefore, that makes it an open set. What about this? That's a closed set. Why is that a closed set, Professor? Because it's the complement, being this R, this is the same as the real numbers. That's the complement of an open set, the empty set. And remember, the empty set is open. Why is that? Here is the empty set. Can you find the empty set here? Where's the empty? I don't see the empty set, Professor. Yep, it's here. That's the empty set. Why is that empty, Professor? Because this is, by definition, the set of real numbers that are bigger than 5 and smaller than 2. Therefore, this set is going to be empty. Why? Because there are no real numbers that are bigger than 5 and smaller than 2. Or can you find a number that is bigger than 5 but smaller than 2? No way. There are no elements in this set. That's why this set is the empty set. Therefore, the empty set is an open interval. All right. So therefore, being this the complement of an open set, that makes this set closed. All right, so what about this one, Professor? That's open. How do you know it's open? Because the empty set is open. It's an open interval. So what about this one, Professor? This is closed. Oh, gosh, you're confusing me, Professor. Wait, hold on. That's closed because this is the complement of an open set. Which one? The real numbers. And why is the real open, professor? Because the real numbers, this is the real numbers, that's an open set. And being this the complement of an open set, that makes it closed, right? Let's finalize this. We have this, that's the union of two open intervals, that's open, and this is the complement of an open set that makes it closed. Take a look. These are closed sets and these are open sets. Therefore, you have won a smiley face because you finished this and you have won a smiley face here. Thank you very much.